Hi everyone, my name is Casey Gamble and today I will be discussing STEAM in upper elementary classrooms or grades 3 through 6. So today we are going to discuss what STEAM is, why we should use it in the classroom, precautions that we need to take when using STEAM, what it looks like in action, and then we're going to discuss some activities. So first I want you to talk amongst yourself about what STEAM is. So if I was actually presenting this in front of a bunch of people, they would discuss what they think STEAM is. And no, I'm not talking about steam, the vapor that happens when water gets really, really hot. We're talking about science, technology, engineering, arts, and math. So I would like for the people watching to discuss what they think STEAM education looks like in a classroom or what it is. So STEAM is science, technology, engineering, arts, and math, just like I said. But it's a little bit more than just, an acronym. It's also an integrated approach to learning in which these 5 categories are applied simultaneously rather than practiced separately. So it's really just a type of lesson that you can teach in the classroom where instead of teaching all 5 of these categories separately, you're putting them all together so that students learn how to use them simultaneously and they can kind of cross over the information. And we're going to talk a little bit more about what STEAM is and what it looks like. So if you have time to watch this video, I definitely recommend watching it. It's definitely going to tell you a lot more about what STEAM is, just like I would use it as an introduction to kind of get people's feet wet when it comes to learning about what STEAM actually is, because most people have no idea. Okay, so a lot of people are going to be confused when you say STEAM instead of STEM. So I would like to discuss the difference between STEM and STEAM. STEM, bottom line, it just doesn't include art. That's the difference in STEM versus STEAM, the acronym. But it's also a little bit more than that, and that's something that I didn't know. STEM focuses on scientific concepts, while STEAM focuses on those concepts through inquiry and problem-based methods. And they're trying to figure things out using a creative process. So that's kind of where the arts are involved in the creative processes that they use. Is like building something rather than coming up with hypothesis and leaving it there, if that makes sense. So next is why use STEAM in an upper elementary classroom. A lot of people think that STEAM, especially when you talk about creativity and arts, they think it's more lower elementary and in upper elementary because students will sit there and listen to you. You can just kind of lecture and teach them like teacher-led instead of student-led learning, and that's not at all the case. So we need to use STEAM in upper elementary classrooms for multiple reasons, and the first and what I think is most important is engagement. I always like to use the analogy, think about it. How long does it take before you space out or check your phone during a presentation or lecture? Kids have much shorter attention spans than we do as adults. And we have to remember that even though upper elementary kids are older, they're definitely still kids. And, in the classroom, it's supposed to be engaging and loud and active. And STEAM is just such a great way to incorporate that. Students love STEAM lessons. It's super engaging and very real world, and it's something that grabs their attention very quickly. STEAM is also super important to use because of the experience it gives students, and this is something that I've learned a lot about since researching STEAM in depth. STEAM in the classroom helps prepare students for the 21st century global society that requires creative thinking in order to prosper as citizens. Our world has changed so much since we were in elementary school, so we do not need to be teaching the same way that our elementary teachers taught us, because they taught us to prepare us for the world that we were growing up in, but the world is completely different now, and we need to be teaching our students in order to prepare them for this technologically advanced world that we now live in. Studies show that in 2018, over 8.6 million available jobs were considered STEM positions. So what this means is if students go to college and major in what's known as like a STEM field, then they are much more likely to get those jobs. And that's a lot of jobs that are needing STEM people. And it's because our world is just so technologically advanced. There's so much more in our world that we need to know about than when we were growing up. And the jobs are different now because of that. So if you expose students to STEAM while they're younger, then they're more likely to kind of have an interest in it and grow up, with that mindset of, transitioning different topics and stuff. And I'm about to talk a little bit more about that. So transferability. Students who participate in STEAM education are able to transfer their knowledge from one topic to another more successfully due to the integrative structure of STEAM. So in STEAM, you're using science, technology, engineering, arts, and math simultaneously. You're using them all at the same time. So if you have a math formula that you might need to use when engineering something or when building something, you're more likely to just know that you need to use that math formula instead of being like, well, this is building, this is not math. Students are able to transfer their knowledge much easier. And lastly, STEAM is so much fun. You should use it, if for no other reason, in your classroom than because it's hands-on and it's student-led and it's so interactive. Not only are your students really going to enjoy it, but you as a teacher are really going to enjoy it as well. I definitely think it's one of the best ways to teach students because it is so interactive and discovery-based. You may be wondering if STEAM is appropriate for your classroom. And the short answer is yes, it is. But differentiation is key. Like with any other type of education or strategy that you're using, STEAM lessons can benefit any student with the right accommodations. You have to know your students and plan accordingly. Additionally, it is important to make sure your students know any background knowledge that they need before you start a STEAM lesson. If you want students to build a boat without it sinking, for an example, they need to know why boats sink, if that makes sense, or else they're not going to understand how to make this boat without it sinking. And yes, there is trial and error, but they just need a little bit of background knowledge on that before you throw a project like that at them. And it also needs to be relevant to the rest of the stuff you're talking about in your classroom. So chances are you're already going to be covering that background knowledge anyways. What does STEAM look like in an upper elementary classroom? Oh my goodness, it's controlled chaos, and it's so much fun. This video, if you have a chance to watch it, is based on a school out of Atlanta, and it's a STEAM school, and so everything that they do is centered around STEAM education, and it is so amazing. These students are so engaged all the time. It's loud, it's crazy, it's interactive, and students are so invested in their own education, and it is just absolutely awesome to watch. So if you ever get the chance to watch this video, if you don't watch the other video, if you don't watch the rest of this presentation, watch this video because it will really pull on your heartstrings and show you that when you're engaged as a teacher and you're willing to go the extra mile for your students, it definitely makes a difference. So what else does STEAM look like in an upper elementary classroom? It's problem-based, and that's one thing you're going to see in that video. STEAM lessons are based on real-life, social, economic, or environmental problems. And because of that, students are engaged because the problems are personal and they can relate to them. One example is cleaning pollution in the ocean or how to eliminate waste. And that's something that students hear a lot about recently. And so that's something that they're really going to be on board for. And the article that I have linked here will tell you a lot more about what STEAM looks like and how it is problem-based and it's project-based. So if you get a chance to look at that, I definitely think it's a good read. It's a little long, but it's really good. So this picture, you can see these students are building, and they're trying to figure out a solution to a problem. So I just really like to show that because it is problem-based and project-based. It's not just students saying, well, this is what I would do. It's students actually doing it. STEAM is also student-led. Students are going to design, investigate, hypothesize, test, discover, and conclude. And my key word here is with teacher guidance as needed. Teachers are not going to be telling their students how to build something, how to design something. how to program something in a computer. Students are going to be doing it all themselves. It's very discovery-based and student-led. And because of that, students are able to kind of manipulate it however they need to make sense in their mind. Everybody kind of takes things in differently, and every student's going to take something different out of STEAM education. And that's okay. Students are going to take what they need. So in this picture, you can see the students are talking, they're loud, and they're kind of doing it as a group. They're not doing it with a teacher telling them what to do. So I really like this picture, and you can kind of see under the boy's hand, he has, it looks like an instruction manual to kind of guide them, like I was talking about, and keep them on the right track, because it looks like they're building like robots or something like that. But there's not a teacher standing in front of the classroom saying, you're going to do this, and then this, and then this. They're doing it on their own, and every student's going to work at a different pace, so I think that's really awesome. STEAM is also high noise level. STEAM lessons require discussion, questioning, and many failed attempts. And honestly, students are going to be talking about what they did wrong, what other students are doing right. They're going to be looking at other groups, but it's going to be loud. It's definitely not going to be working quietly and independently for the majority of your lesson. If you want students to try to design something on their own or think of what they would do before they get with a group, then I think that's great. But students do not need to be doing a STEAM lesson completely on their own, because a lot of times they're going to need those ideas from other students, or other students are going to point out things that they might not have thought about. So in this picture, you can see 3 students like really deep working on a project, once again building something, it looks like. But then there are other students everywhere, and that kind of helps you get a sense of the controlled chaos that is STEAM education. But it's so worth it. It's so much fun, and every student is benefiting from it. It's not like some students are and then other students are just kind of slacking off. Every student really gets engaged in STEAM education when you plan out the lessons like that. And I also wanted to mention this, STEAM education, what does it look like? STEAM spaces or maker spaces are something that are really big right now for a lot of teachers. And this article tells a lot more about those spaces. It encourages exploration in the classroom and allows for the planning of STEAM lessons to be less stressful for the teacher. If you already have all the materials in one spot, or you have one spot where groups can go one at a time and build whatever it is that they're building that day, it's just so much easier. It's a lot less prep work, and it's a lot easier to clean up. And it's just a lot more organized. So a lot of teachers are opting for maker spaces or STEAM spaces. However, it can get pretty pricey, and I know some teachers don't have access to that kind of stuff. So if you can't do that, it's okay. You can still do STEAM lessons if you don't have a dedicated space for STEAM. When planning a STEAM lesson, there's a few things you need to ask yourself. First, does it align directly with your standard? And I'm going to go into that a little bit more in detail in just a few minutes. But you also want to know, are all 5 elements of STEAM included? When I planned my STEAM lesson, I literally made a checklist that had STEAM, and I was like, science, how is this helping with their science? Like, what are they learning in science? Is this benefiting that? Technology, what are they using? That's, technology. Engineering, what are they building? What are they trying to engineer? Arts, it's a little bit more difficult to incorporate arts sometimes, but even the smallest stuff is still considered arts, even if it's not super artistic, I guess. But the creative process is definitely a part of the arts. And you can also do, if you build a boat, which boat looks the most professional or the prettiest, or if you're doing a younger grade, you can do like which one is the most colorful, stuff like that. And then mathematics is pretty easy. It's not just like math formulas, it's also like shapes and stuff like that. So if they're building something, you can say, well, is this the right shape so that it doesn't collapse or something like that. You also need to think about how much time is required and plan accordingly for your class. You don't want to spend the first 45 minutes of your class lecturing if it's going to take an hour and a half to actually do the STEAM lesson, the like engaging part of the lesson. So you might want to do some background knowledge the day before and then come in the next day ready to do your STEAM lesson. Which brings me to, do the students need to learn any background knowledge? We talked about that a few minutes ago.